Britain has a long industrial heritage stretching back over a century. From the earliest days of modern manufacturing, the UK has been a force for innovation and growth. There have been many changes over the years, but engineering continues to thrive. The move towards high-quality, high-value production has led to a renaissance for many engineers, able to compete with the world by offering the best products available. Over the next half hour, we'll talk about the place engineering has in the UK economy and how it can continue to thrive into the future.
I think the UK is a good place to be an engineering company. Whilst there are problems and a lot of engineering and production has been moved abroad to low-cost countries, we have proven with automotive, for example, that we can produce cars effectively and cost effectively in the UK. However, I think in the future, more and more things will probably go abroad unless UK consumers are prepared to pay more for UK products. But there is an exciting background of highly specialised companies that I think bodes well for the future.
I think engineering, with the wind tunnels, the history, the legacy, the fact it's so unique, you need to be a sort of special kind of person who's passionate about wind engineering, about the understanding of it, solving problems, really getting to grips with engineering. You're not turning a spanner, you're actually fixing problems.
The British engineering industry is quite often, if one listens to the media, is, you could almost think, non-existent. But in fact, I believe it is alive and kicking. But it's not necessarily the sort of large companies, large manufacturers out there. It is made up of a lot of very small, very enterprising businesses that are in many cases leaders in their fields. And that, I think, is good for the future, and it shows that there is proper vibrancy within the sector as a whole, but it doesn't deny that there are problems.
In the modern world, every sector is constantly changing. New techniques and technologies are driving constant change across our whole economy, and nowhere is that more true than in engineering. Today's customers expect more from their products and expect to see new innovations coming through every year. Changing with the marketplace is critical for success as an engineer.
Every year something changes in the market, the technology moves on, and you have to adapt. Every company has to change. Over the years we've taken on CFD, we do a lot of that sort of technology. We've increased our productivity on our models, we've got leaner processes, we've increased the fidelity of our models to increase the accuracy of everything we do. But we've listened to our clients and we've tried to find out how we can solve their unique problems.
Since we started in 1984, the market has changed enormously, not only in terms of the way we sell things, with the internet now becoming a very important way of distributing our products all over the world, but also the whole way that stuff is manufactured. The basic ideas of, say, gear pumps, which form a major part of our business, the basic concept has stayed the same and has been the same for probably nearly 100 years. But the processes in machining and manufacturing these things have allowed us to get closer and closer tolerances. Material technology has meant that we are able to now make things with stronger bodies, stronger gears, and the whole science of that has meant that we can now get improved pressures, better flows, higher efficiencies than we ever got before.
I don't see too many changes in the technology of our seals in the future. We're always improving the seals as we go, but I think that the changes and the improvements are more due to design and our own know-how and understanding of how products work in difficult and in new applications. So we're constantly being challenged by new technologies. For example, in electric vehicles, there are lots of high-speed motors and things, and these motors offer difficult challenges in temperature control and also speed.
Wind in its own right is not incredibly challenging. It has been studied for several decades. What is challenging is the bespoke nature of some of the designs that we do tend to get involved with. Obviously, designers do tend to push the boundaries of what can be done every day, which is very exciting, of course. And we, as wind engineers, are there to actually guide them and make sure that they can deliver successfully and economically the vision they have.
Along with Germany, I think the UK has got a good reputation for high quality products and innovative products. I think one of the main issues we have is that when we do develop a new product, all too often we see that technology go abroad, so it's actually lost to the UK. So we don't benefit from that innovation in the longer term.
Today's engineers offer more than just production services. More and more, we're seeing engineers offering a more collaborative, bespoke service for their clients. Taking a role in product design helps engineers to leverage their expertise and provide a greater value for their customers than offshore producers could achieve.
Typically, when a customer comes to us for a new component, we would probably visit them, take a look at what they're doing if we're not already familiar with it. Then we would gather all the information related to the component and the criteria that they're working with. So things like temperature, speeds, pressures, this type of thing. We would then input all of this data into our design department, and the guys would look at it. They would come up with a basic design, put that then through the FEA system, and model the design until we're happy with it. Then we would move on to production. So there'd be some initial sampling. Those samples would then either be tested by us or tested at the customer for initial approval. And once we've been through all the testing procedures and everyone was happy that the parts had actually functioned correctly and to the satisfaction of the customer, then we would move on to production.
Our product lines are entirely chosen on where we feel there's customer demand. So it's in response to what customers are already taking and building on that, expanding on that, or what they're specifically required. In some cases, we might make a pump for someone and they then ask us for another one. So we then actually will buy that from the manufacturer if we can, and we'll then stock it, because we're not set up to compete with the main line. We're set up to give people a competitive price.
The advantage of the wind tunnel compared to numerical simulations, especially when used within the context of relatively short timescales, is that it has the ability to model in a much more robust manner the turbulence which is in the wind. Turbulence is what actually can be perceived as relatively annoying when you walk between high-rise buildings. So if you think about that sort of force that can flip up skirts or turning umbrellas inside out, that is the turbulence. And that's what's quite difficult to capture inside a computer still today.
Investment is a critical part of engineering. New machines and new techniques are constantly being developed, and embracing these advances is essential to keeping a competitive edge. Making the right investments can be extremely challenging. Finding the right times to buy into new technologies requires both a clear understanding of the market and a robust knowledge of the technology. But for those who make the right investments, there are huge advantages to being the first to market.
There are businesses out there, very vibrant, particularly small businesses, who don't look on needing a payback within 6 months, but actually look to a long-term return on things and are investing in new equipment. And you just have to look at sort of machine tool sales are very strong in the UK at the moment, because firms are investing in new equipment. And it is essential that we do.
Our life is inevitably becoming quicker and quicker every day. Everybody is expecting results yesterday. There is the need to actually push quite hard in new technologies, a smarter use of big data handling, for instance. So I can see quite a lot of potential in technologies like machine learning and artificial intelligence.
I think it's been really important for us to keep up with new technology and have new equipment, and also training our people. We can't afford really to drop behind. We're trying to be at the forefront of sealing technology, and this really demands that we have up-to-date equipment and look forward to where sealing is going to go in the future.
Automation is a key factor in it, particularly in the UK, because we need to take the labour cost out. The ability of the automation, I think that things like additive manufacturing, which is a very new process, it still has a long way to go, but it has the potential to make products better and faster, but it's a few years away from that. At the moment it's very expensive.
Computer simulation, numerical simulation started becoming used commercially, especially in wind engineering, roughly I would say between 10-15 years ago. So in that sense it is a relatively recent trend in the industry.
Modern engineers need to have a broad base of expertise. They cannot afford to be overly focused on singular materials or approaches. Bringing together a variety of techniques and the expertise to bring together different materials is critical to serving the modern market and delivering ever more complicated products.
The manufacturing of seals, the way it's carried out at Race-Tec, is through a process called compression molding. So typically in a seal there may be a metal component, and then rubber component, and a PTFE component. All of these parts go into a mold, and it goes back into an oven under pressure and remains in the oven for typically 5 or 8 minutes. And when that part comes out, it's in a semi-cured state, but it's fixed. So dimensionally it's stable. So then once the part comes out of the mold, it goes across to finishing and trimming and inspection, and it's checked to make sure it's dimensionally accurate and there's no faults in the rubber.
In a broader sense, fluid mechanics is actually used to assess, if you wish, the aerodynamic performance of other types of structures as well. It can be used to, for instance, optimize the performance of Formula 1 cars or supercars. Can be used to optimize from an hydrodynamic point of view structure which lies underwater, for instance, or you can take it to another extreme and it can be used to study, for instance, biological fluids like blood.
Hydraulics are a major part of an enormous number of industries, but probably go pretty unnoticed. Yes, when you look at an excavator and you see arms extending or buckets lifting or that sort of thing, that is quite obviously hydraulics. But then you look, for example, at the gritter going past us at the moment, for example, the conveyors and the spreader are probably all driven hydraulically. The brakes in everybody's cars are hydraulic. Quite often you use in disabled access machinery for lifting people in and out of baths, it's hydraulic. So hydraulics pervade really every area of our lives.
People are a critical part of every business. In manufacturing, achieving high-quality results demands a well-skilled workforce who are able to adapt to a changing workplace. For many engineers, the arrival of greater automation has driven investment in skills and training, ensuring that staff can continue to contribute and bring fresh ideas into the business.
UK employers have been too ready to take on relatively low-cost labour from Eastern Europe and elsewhere, rather than actually investing in improving the productivity in their businesses.
One of the main challenges we face at the moment are finding the right people. And it's sometimes even finding qualified people is okay, but it's finding the people that can actually help move our business forward. So this is even more challenging.
I think there's been a big problem with new talent coming in. And I think one of the other big problems is that how certainly from looking at it from a mechanical engineering, which is basically what hydraulics, the sort of field that hydraulics most closely relates to, is the lack of practical knowledge that graduates coming into the industry have now, whereas before they had to do an element of practical. Now a lot of things is theoretical, and they have very little, or certainly some of the ones I've come across, have very little perception of how materials, what materials feel like, what actually happens when you cut metal, what happens when you actually integrate. Everything's been on paper or modelled on, and it's not the same thing. You cannot model what a bit of steel weighs. You can't, and it's this whole, the practical side of things, I think, has been ignored.
In the UK, there appears to be a distinct lack of interest in engineering from young children. I know when I look at my own sons and compare with how I came through engineering, it's not encouraged in school. The profile of it is not high enough in schools.
The whole business of getting young people to actually see engineering for what it is and see the breadth of what the breadth of skills that are there, the breadth of areas where it is used. I mean, there are a lot of, what I find very sad is there are a lot of people my children's age who have gone to university to do engineering, and they have no intention of doing engineering when they come out, which to my mind seems they all want to go into the city or something like that, which actually, if they go into engineering, they can probably in the long run do as well and probably have a much happier life and more fulfilling life than sitting in front of a computer screen counting their money.
There is already a shortage of engineering staff in the UK, and it's something that we should tackle during the Brexit process.
The next generation of engineers is a critical concern for today's engineering sector. We often hear how young people are less interested in joining the engineering sector, and the industry has made real efforts to change that. Through apprenticeships and graduate programs, many companies are bringing young people into the workplace and giving them a taste of what the industry is really like.
The engineering industry has to start taking a more active role in attracting talent. I think the key to this is getting people involved from an early age and really building that interest. We're going to need to start looking at talking to local schools and teachers and getting young people interested in engineering.
We do get a lot of graduates inquiring about it. We get people that have done, say, maybe aeronautical engineering, mechanical engineering, civil engineering. There's quite a lot of sectors in like degrees that can flow into this field, which is great. Even mathematics and analysis and statistics will flow into this field. And we find that if you're the right type of person that's got this passion to learn, then we can mould you and teach you the different parts that you need. We do get that. So we take on graduates and apprentices most years, build them up through the company so they have day release, back to university, things like that. A lot of the time we take them on as our wind tunnel engineers, wind tunnel technicians, but then they move into the project management engineering teams, and we basically build people up through the company.
Apprenticeships are a funny connotations for different people. But what actually being an apprentice, if one goes back to the basic meaning, means somebody who will learn from someone else, learn from someone who has already learnt how to do something. And I think the problem we can have with apprenticeships, and I think they're good, but they should not become a sort of rigid structure by which this is the apprenticeship path, because we are all apprentices and we should all be apprentices all our lives.
We have some top quality universities that are driving research and development and working very closely with UK companies. That pushes us forward, and it gives us the benefit of being able to work with those innovations and technologies and monopolise on them before they can be picked up in other countries.
Young people coming through university are often not looking to get into the more practical side of engineering. So this does create some problems for us. I think we really could do with getting the prestige back in engineering, so that people do look at it as a career. In schools these days, they no longer seem to teach things like metalwork and woodwork and technical drawing, which are things that typically engineers of today would have done when they were at school. It more seems to be design and technology, which doesn't really give them maybe some of the hands-on training that our generation possibly had. And also the type of equipment people are buying these days. We're in rather a throwaway society. I think many of the engineers today, when they were growing up, would have been fixing their own bicycles, fixing their own motorbikes, fixing their own cars. Whereas nowadays people tend to buy things, and if they have a problem with their high-spec bicycle, they take it to the bicycle shop and get it fixed. So a lot of these hands-on skills have been lost, and I think that's something that maybe the government, certainly education and industry, needs to try and improve on and start at a younger age. I think it's important for industry to engage with schools and universities. It is difficult for smaller companies to do this because often the resource and the time isn't available. So I do think it's something that the government should probably lead with, and larger industries should try and get maybe more schemes and more support for younger people to try and get them back into engineering and put the prestige back in engineering.
We also offer 6-month internships for people coming out of university. We often find that this gives them a great foundation for moving on somewhere else in the engineering world, or they come back to BMT and start their career with us. As a company, BMT is highly dependent on attracting staff and talent from the EU and beyond. Moving forward, there's some uncertainty over whether we'll still be able to do that, and it's a real challenge to the industry.
It's an exciting time to be in engineering. The future promises many exciting changes in the coming years, with new materials and advanced products becoming the standard across the industry. The only real certainty for engineering is that it will remain critical to all of us, and the kind of products we need will continue to change.
I think the future of construction is incredibly exciting. We can already see today where the future is actually going. We've been using, for example, 3D printing technology here at BMT for quite some time. We have more recently bought a couple of robots which are helping us in making the models that we need to use for the testing that we are conducting. And then at the same time, if you look at the wider industry, the same kind of technology, and therefore robots, 3D printing, has been used or is started to be used more recently. We know that, for instance, there's a strong push, especially here in the UK actually, on modular constructions, which is nothing particularly new, but people are actually pushing boundaries, started using that technology for taller and taller buildings, and obviously that's why they need input from people like us to actually making sure that everything is going to be designed and built in a very safe way.
Growth in the coming years for White House products is going to be, I always think you always think it's going to be a continuation of what you're doing, but I found over the years that does not work. We've had to sort of not exactly reinvent ourselves. We've always done hydraulic since the very early days. We've always done hydraulic components, but we've seen how we used to sell a lot of bulk products, lots of, say, one part number to one or two customers, and that was formed a large part of our business. That's almost totally disappeared, and so now we're selling a large range, but in very small quantities, to a large number of people. I see our sort of skills developing in terms of increasing the range of pumps that we actually manufacture here, which basically started as something to complement the range that we distribute, and it still does.
I think the future is quite exciting for everybody. There are lots of high-tech industries within the UK, and if we take our own market, for example, we predominantly deal at the moment with motorsport. But supporting all of these high-tech motorsport companies around the UK, there are a significant number of small engineering companies, high-tech engineering companies, which are supporting this industry. And all of this technology and these high-qualified, high-class people are available to the rest of the UK industry. And it's something we should be probably proud of, and something that industry in general should make more use of. I think in the future more and more expensive consumer products will be more and more customized. There's always going to be a place for cheap repeat products, plastic spoons, plastic cups, for instance. But I think in the future there will be more and more demand for the consumer to be able to select the particular qualities that they want from a given product. And to some degree that's what we're already doing here at Race-Tec. More consumer products will be moved abroad to low-cost economies, but I think for the UK there's still a big role for specialised, innovative companies to come up with quality products, reliable products that they can put out into the market. I think the key areas for the future will be things like robotics, electric vehicles, battery technology, environmental products, and maybe nano materials and this type of thing. So I think these will be the strong areas for the UK in the future.